Researchers have found the brightest burst of light ever recorded.
The depth of space in scope and color like we've never seen before.
The James Webb Space Telescope, JWST, has recently made a discovery that has the scientific community abuzz with curiosity and excitement. In its exploration of the cosmos, JWST has detected 5 galaxies so distant, so different, and so inexplicable that they are believed to exist beyond the boundaries of our known universe. These galaxies defy our current understanding of astrophysics, challenging our notions of what lies beyond the observable universe, and forcing astronomers to rethink the limits of cosmic exploration. The implications of these discoveries are profound, suggesting that our universe may not be the only one, that we may, in fact, be on the brink of uncovering evidence for a multiverse. Before we get started, hit the like and subscribe buttons for more exclusive news. When JWST first detected these 5 mysterious galaxies, scientists were initially reluctant to believe the data. Located at the outer limits of what our telescopes can observe, these galaxies appeared to exist at distances and in configurations that did not fit any known cosmic model. The first readings from JWST suggested that not only were these galaxies far beyond our observable universe, but they also had unique structures, properties, and energy signatures that contradicted our current understanding of galaxy formation. Unlike the galaxies in our universe, which tend to follow established patterns based on gravity, mass, and the presence of dark matter, these newly discovered galaxies appear to operate according to very different rules. Their discovery suggests a form of cosmic evolution that operates by unknown principles, revealing a potentially deeper layer of reality that has eluded us until now. The existence of these galaxies is enough to shake the foundations of physics and standard cosmology. The observable universe is thought to be about 13.8 billion years old, and light has only been able to travel a finite distance since the Big Bang. This constraint defines the observable limits of the universe, creating what scientists call the cosmic horizon. Objects beyond this horizon are thought to exist, but cannot affect or be observed by us because of the finite speed of light. However, the galaxies detected by JWST appear to lie beyond this horizon, suggesting that they may belong to an entirely different reality, or perhaps even another universe. If these galaxies are indeed from a realm beyond our own, it would mean that the cosmic horizon is not the ultimate boundary of existence. Instead, it may be a perceptual limit imposed by our position within a much larger and more complex cosmic structure. The discovery of these galaxies challenges one of the most fundamental principles of physics, that the laws of nature are universal. For centuries, scientists have assumed that the same forces that govern our solar system, galaxy, and universe apply universally. But JWST's findings suggest that these distant galaxies may operate under a very different set of physical laws. Some of these galaxies exhibit energy levels that are difficult to explain using our current understanding of thermodynamics and quantum mechanics. They appear to be powered by unknown sources, possibly new forms of energy that do not exist or are not yet understood in our universe. This revelation isn't just surprising, it's revolutionary. The idea that other universes with different physical laws might exist has been the subject of theoretical speculation for decades, but now we are faced with what could be concrete evidence of such a reality. The implications of these findings extend beyond the field of astrophysics into the realms of philosophy, metaphysics, and even spirituality. For centuries, humanity has grappled with questions about the nature of existence, the origins of the universe, and the possibility of other worlds. The discovery of these galaxies adds a new dimension to these age-old questions, suggesting that the reality we experience is only a small part of a much larger and more complex system. If there are other universes with different physical laws, it could mean that our universe is just one iteration in an infinite tapestry of realities. Such a possibility would mean that our understanding of existence is only partial, and that there may be other beings, possibly even other forms of life, living in these alternate universes. Another striking feature of these galaxies is their apparent age. Current cosmological models suggest that galaxies take billions of years to form, growing gradually as stars coalesce and galaxies merge. However, the galaxies detected by JWST appear to have formed in a fraction of that time, and have fully mature structures that are inexplicably old, even by cosmic standards. This discovery may indicate that these galaxies formed in an environment radically different from our own, where time and space may operate differently. If time flows differently in these regions, it could mean that our understanding of time as a linear, constant progression is only a localized phenomenon tied to the specific physical parameters of our own universe. Such a discovery could revolutionize our understanding of time itself, suggesting that it may be malleable or even multidimensional in other realities. The nature of the light coming from these galaxies adds to the mystery. Normally, light from distant galaxies appears redshifted due to the expansion of the universe, a phenomenon known as the Doppler effect. However, the light from these galaxies has peculiar spectral signatures that do not fit neatly into the redshift paradigm. Instead, their light suggests unknown forms of matter or exotic particles that do not interact with light in the same way as the elements found in our universe. These spectral anomalies could indicate the existence of new types of matter or energy not yet observed in our reality, possibly including states of matter that are theorized but not yet proven, such as dark energy or hypothetical particles beyond the standard model. Such exotic matter, if verified, would provide insights into the building blocks of other universes, giving us a glimpse into realms that operate by fundamentally different rules. This discovery also reignites the debate about the multiverse. While the concept of a multiverse, an ensemble of multiple universes existing simultaneously, has long been considered speculative, these findings from JWST may provide the first observational evidence to support it. If these galaxies are indeed from beyond our universe, they could be part of a vast multiverse in which countless other universes coexist with our own. Each of these universes could have its own unique set of physical laws, cosmic structures, and forms of life, representing variations on reality that we can only begin to imagine. The idea of a multiverse has been advocated by some of the most respected physicists, such as Stephen Hawking and Max Tegmark, but until now it has been impossible to obtain observational evidence to support it. The discovery of these galaxies could be the first step towards proving the multiverse theory, a breakthrough that would fundamentally alter our view of reality. The possible existence of a multiverse also raises profound questions about the origin of our own universe. If there are indeed other universes beyond our own, then it is possible that our universe was not a unique, isolated event. Instead, it may have been one of many universes that formed in a cosmic cycle or as part of a larger structure of interconnected realities. This idea could have significant implications for our understanding of the Big Bang. Traditionally, the Big Bang is seen as the beginning of all things, the moment when time and space were created. However, if other universes exist, then the Big Bang could be just one of many such events, part of an ongoing process of universe formation within a multiverse. This would suggest that the creation of universes could be a natural phenomenon, possibly occurring in cycles or through mechanisms we do not yet understand. The discovery also raises new questions about the possibility of communication or even travel between universes. While this idea remains firmly in the realm of science fiction, the detection of galaxies beyond our observable universe invites speculation about whether it might one day be possible to bridge the gap between realities. If these other universes exist in a tangible way, then there may be unknown forms of energy or technology that would allow us to interact with them. Such a possibility, although far-fetched, raises tantalizing questions about what it would mean to connect with and perhaps even visit other universes. Would these other universes be hospitable to us? Or would they be so alien that human life could not survive? Might they contain advanced civilizations that have already found ways to cross the boundaries between realities? The scientific tools we have today are only beginning to scratch the surface of what lies beyond our universe. The capabilities of the JWST represent the pinnacle of human achievement in space exploration, but the discovery of these galaxies shows us how limited we still are. The cosmos, as vast and ancient as it is, holds mysteries that we are only beginning to unravel. JWST has given us a glimpse of a reality we never imagined, one that challenges every assumption we hold about the nature of existence. It reminds us that the universe, or rather the multiverse, is far more complex and beautiful than we can currently understand. The journey to unravel these mysteries has only just begun, and as we continue to explore, we may find that our greatest discoveries are yet to come. These galaxies, with their strange properties and unexplained characteristics, may ultimately serve as a cosmic invitation, urging humanity to look beyond the limits of our understanding. They are a call to adventure, to seek new knowledge and to push the frontiers of science. The discovery of galaxies beyond our universe is a momentous step forward, one that could usher in a new era of scientific exploration and philosophical inquiry. It is a reminder of our small place in a vast, interconnected reality, one that extends beyond the stars and invites us to wonder what lies beyond. One of the most fascinating aspects of this discovery is how it redefines our sense of place in the cosmos. Throughout history, humanity has tried to find its center in the universe. Ancient astronomers once placed the Earth at the center, and even as we expanded our understanding to recognize the smallness of our solar system within the Milky Way, we still perceived ourselves as central to the observable universe. The idea that galaxies exist in other universes turns this concept on its head, positioning our universe not as the sum of all existence, but as a single island in a vast ocean of realities. If these other galaxies exist beyond our universe, they may belong to a separate but equally vast observable universe with its own inhabitants, mysteries, and evolutionary pathways. This radical expansion of our cosmic perspective carries with it a more profound philosophical weight. For millennia, we have pondered the nature of reality, considering whether what we see, feel, and understand represents the true nature of existence. The potential discovery of parallel universes or unknown realms brings a new dimension to these contemplations, suggesting that our reality may simply be one layer of a multifaceted existence. Scientists and theorists are grappling with how these galaxies could exist in such distant, seemingly inaccessible realms. Some propose that they might represent regions of space-time that were once connected to ours in a distant pre-Big Bang era. According to one hypothesis, our universe may have budded off from a larger cosmic entity, like a bubble in a sea of other universes, each with its own laws of physics. This would mean that these other galaxies might have existed before our universe separated from its parent reality, persisting in their own evolutionary paths ever since. Such a notion redefines the Big Bang, not as the beginning of all things, but as a phase transition, a moment when our universe differentiated itself from a more extensive pre-existing state. In the light of these revelations, physicists are re-evaluating fundamental theories in search of frameworks that might explain such distant, inaccessible realities. Theories such as string theory and M theory, which propose additional dimensions beyond the familiar 3 spatial and 1 temporal, may offer explanations. If these extra dimensions do exist, they could represent pathways or channels connecting different universes or realms. Too small to observe directly, these dimensions may hold the key to understanding how seemingly unrelated galaxies could still influence or relate to our own universe. M theory, which proposes an 11-dimensional universe, suggests that what we perceive as separate universes may actually be connected by higher dimensional spaces that we have no way of perceiving or measuring. One possible model, known as the brain multiverse theory, theorizes that universes exist as separate brains floating in a higher dimensional space, sometimes coming into contact and influencing each other. If these galaxies detected by JWST exist on another brain, then their proximity to ours may be an illusion caused by their proximity in higher dimensional space, rather than spatial distance as we understand it. These brain contacts could potentially explain the strange energy signatures and unusual light behavior observed in these galaxies. Our instruments, designed for 3-dimensional space, may be picking up the remnants of energy transfers or gravitational effects caused by the occasional interaction of our universe with another, leaving traces only visible to an instrument as sensitive as JWST. Moreover, the very appearance of these galaxies, with their structures and energy forms so different from any known models, raises questions about the adaptability of life and matter in these alternative realities. If galaxies beyond our universe are real, then they could support entirely unfamiliar types of matter, star systems, and potentially even life forms. Life, as we understand it, is a byproduct of the laws of physics that govern our universe, laws that dictate how atoms bond, how cells function, and how energy flows. In an alternate universe with different laws, life could exist in forms beyond our comprehension, perhaps relying on chemical or physical processes that would be impossible under the conditions present in our universe. This discovery pushes scientists to explore the limits of imagination and scientific conjecture. How might conscious beings, if they exist in these other universes, perceive their reality? Would they see their own universe as the entire hope of existence, just as we have? Would they have detected our universe or others? Such questions push the boundaries of empirical science and bring us face to face with a philosophical realm that defies testing and measurement. Yet with every advancement in technology, from the JWST to future space telescopes that could succeed it, we move closer to turning such speculation into a form of observable science. This potential extension of our empirical reach suggests that we may one day have tools capable of directly interacting with or observing these other realms. What makes this discovery particularly significant is that it forces us to rethink the nature of energy and matter. If these galaxies are governed by different physical laws, the properties of matter there may be very different from those in our own universe. This could mean that matter, energy, and perhaps even consciousness itself are more versatile and adaptable than we ever imagined. For example, what we define as matter may be only a local adaptation of a more fundamental, malleable form of reality that changes according to the governing rules of each universe. If energy and matter can take different forms under different physical laws, it suggests that our understanding of physics is a localized perspective, constrained by the properties of our universe. One tantalizing possibility is that these galaxies may have different forms of gravity or even alternative forces altogether. Scientists have long speculated about the existence of other fundamental forces beyond the four recognized in our universe: gravity, electromagnetism, and the strong and weak nuclear forces. If other universes operate according to different physical laws, they may be governed by forces that we cannot detect or understand. This opens the door to imagining universes where reality itself feels different, where stars don't shine because of nuclear fusion, but because of other unknown processes, and where the bonds that hold matter together operate on entirely different principles. JWST's findings also raise questions about the role of consciousness in perceiving reality. If we are part of one universe among countless others, it's worth considering whether consciousness might take different forms in other realities. In a universe with altered physical laws, could there be conscious beings who perceive time, space, and existence in ways unimaginable to us? Could consciousness itself be a phenomenon that adapts to the conditions of its environment, much like matter and energy? This discovery could lead to a new era in the study of consciousness, one that considers not just the brain or biology, but the fundamental nature of existence across different forms of reality. Perhaps most astonishingly, the discovery of galaxies beyond our universe forces us to grapple with the concept of infinity. The existence of multiple universes suggests that reality itself may be infinite, an ever-expanding collection of realms, each with its own unique configuration. Infinity in this context is not just an abstract mathematical concept, but a tangible reality filled with infinite variations of existence, each as real and concrete as our own. This challenges the way we think about purpose, meaning, and the human place within the cosmos. If we are part of an infinite reality, how do we define the significance of our existence? Does meaning change if our universe is one of countless others, each with its galaxies, stars, and possibly its forms of life? For humanity, the detection of these other galaxies is both exhilarating and humbling. It shows us that even the most advanced scientific tools we possess are only scratching the surface of a vastly complex reality. JWST's glimpse into these distant galaxies suggests that our journey of discovery has only just begun, and that we may be standing on the precipice of a new era in cosmology. It's a profound reminder that every answer we find about the universe leads to new questions, each more profound and far-reaching than the last. The more we learn, the more we realize how much remains to be understood. Moving forward, this discovery will likely drive a wave of innovation in scientific instrumentation, as scientists strive to develop tools capable of probing these alternate realms more directly. We may see a new generation of space telescopes, each more powerful than the last, designed to peer even further into the depths of existence. This quest could ultimately lead to breakthroughs in technology and physics that we can scarcely imagine today. Concepts that seem purely theoretical, like wormholes or interuniversal travel, might one day move from the realm of science fiction into scientific plausibility, bringing with them new possibilities for exploration and understanding. One of the most mind-bending aspects of this discovery is the potential implication for the concept of causality in our universe. Causality, the idea that cause precedes effect, is a foundational principle. However, if other universes exist with different physical laws, then the nature of causality itself may vary across these realms. These distant galaxies may follow causal relationships that are foreign to us, where time may not progress linearly or cause and effect might not operate in the way we understand. Imagine a universe where events are not bound by linear time, where the past, present, and future could intermingle in ways inconceivable to our experience. The existence of such galaxies could challenge our deepest assumptions about temporality, forcing us to ask whether causality, as we know it, is merely a byproduct of our universe's particular configuration. The structure of space-time is another area thrown into question by these findings. In Einstein's general theory of relativity, space-time is a continuous fabric that can be stretched and bent by the presence of mass and energy. But if these galaxies belong to another universe, they might exist within an entirely different space-time configuration. Another critical aspect to consider is the possible interaction between these galaxies and our own universe. Could these distant galaxies exert some form of influence on our reality, perhaps in ways we have yet to detect? Could the strange properties of their energy signatures be the result of subtle interactions with our own universe, possibly leaving imprints in the form of gravitational waves, exotic particles, or even variations in the cosmic microwave background radiation?